Hey Algebra 2 students, this is lesson 12b on our first module. Today you're going to need a sheet here, which you can see the front and back of. And then on the other side, you're also going to need to have your binder with you. Open to page 61 is where we'll be working out of today. And that's actually it. We'll come back to the lesson summary at the end, kind of talking about both 12a and 12b. So let's dive right in. Our objectives for today, the first one is to be able to find solutions of cubic polynomials by grouping. And then I also included an objective where we have to be able to find solutions to quadratic equations. We'll see why that's important later. Once we start finding solutions with grouping, we may need to use some of our other tools for to finish our problems, but we'll come to that later. All right. On this do now, which may be different than the one on your handout, that's okay. Let's look at it right now. I gave us a term. It says, what's the greatest common factor in the binomial below? So we'll need this skill later today. When we say greatest common factor, we need the biggest factor that's in both parts of this binomial. So looking at this one, the only factors in this first part are 2 and x. And I guess we can always also include 1. Right? 1's a factor of every number. 2 times 1 and x. Those are all the factors I can think of. 2 is prime. We can't split it up anymore. And for the second one, well, I could take out a 2, and that would leave me with just 2 left over. So we could write 4 as 2 times 2. So what we've done here is we've just split up all the factors of the first part, all the factors of the second part, and now we're wondering, what's the biggest one that they have in common? Well, they don't have x in common. X is only on this left one. There's no x in the right term, so we can't do anything with that. The biggest one it looks like they have in common is 2. Right? 2 is the biggest one that both of these numbers have in common. And you may not need to break it down like this. You may be able to see that, like, looking at 2x and 4, it'd be like, what's the biggest number that goes into both of them? Well, 2 goes into 2 for sure. 2 also goes into 4. So what's the greatest common factor binomial below? I would say it's 2, because that's the biggest one that's in both of them. It says factor out the number you identified above and fill in the blanks below. So we want to imagine, like, now that we know 2 is a factor, we want to pull it outside. So we want to imagine, like, dividing it out of both of our terms. So let's find for this first term, 2x divided by 2. I know that the 2 and the 2 are going to divide to just 1x, plus 4 and the 2 will divide to 2. And then since we divided a 2 out of both terms, we need to replace it. It's being multiplied by the whole thing now to make it equivalent. So we see 2 times x. If we were to distribute this back through, 2 times x would be 2x, yep, and 2 times 2 would be 4x. So we've just rewritten this expression, the 1x plus 2. We've rewritten this expression with the greatest factor pulled out. So that's going to be really important in our objective for today, so that's why I introduced it during the do now. Let's go right to, let's scroll down a little bit and come through. This is not something we're going to go through all the way. I just want to make us aware of the type familiar with factoring. There were these 3 formulas up here: difference of squares, difference of cubes, and sum of cubes that we introduced in lesson 6. Those are the patterns we need to be able to recognize, right? It was like a squared minus b squared, a squared minus b, or a cubed minus b cubed, a cubed plus b cubed. And then down here under quadratics, there are a couple methods. The diamond box method is what we originally used to factor. Completing the square is an option. It's valid. If you know how to do it, great. We haven't covered it, and we probably won't have time to this year. Quadratic formula is the one we talked about in 12a. It works for any kind of problem, anytime. What we're going to focus on today is if we have any cubic functions. So that's functions with degree 3. And the method that we're going to focus on today is grouping. So let's dive right in. This is a problem actually from your binder. So go to your binder at page next page from where we left off. 12a. Yeah. 61. Example 2 in this lesson we're going to talk about. So we want to factor this, but we don't seem to see, we can't use any of our normal methods. So what we're going to do today is see if we can group together our terms to find out some common factors and then be able to pull them out, just like we sort of pulled out a factor of 2 from the activity in Arduino. We pull the 2 out of that binomial. So what we want to do first is we want to group our terms based on ones that have common factors. So let's take, for example, this x cubed and positive 3x squared. If I'm looking at those two as a group, I'm thinking to myself, what are some things that they have in common? Well, I notice right away that both of them have x's, right? Both of these terms, first term in this group, the first term in this group has 3 x's being multiplied together, and the second term in this group has 2 x's being multiplied together. So those two do have something in common, so I'm going to take them as so I'm going to kind of just start rewriting our problem down here. X cubed plus 3x squared. I'm writing them as a group, just kind of off to the side, putting parentheses on them so I know that I'm talking about a group. Looking at this other group over here, I'm going to do this one in blue. I'm seeing to myself if I notice anything in common. Well, right away, when I look at this, I notice that there's a negative on both of these. So they at least have a -1 in common. Both of them have a -1 as one of their factors. Then I look at their numbers. Well, 9 and 27, I know 3 goes into 9, and 3 also goes into 27. So 3 is a factor of both of those. It's not a very big factor. Let's see if there's a better one. Well, 9 goes into this first term. 9 is a factor of this first term. And then is 9 a factor of 27? 27, I'm checking right now just in a calculator. I'm doing 27 divided by 9 to see if it's a factor. And sure enough, it is. 9 is also a factor of 27. So it looks to me like these definitely have some in common. We'll come back to what their exact thing in common is in a second. So I'm going to rewrite them as a separate group over here, 9x minus 27. All right. So we've just taken our two terms. We've decided that these two should be in groups because they do have factors in common. Hopefully we can pull out those factors and we'll get something that helps us simplify it further. So looking at the first one, I'm thinking to myself, I need the biggest common factors. So first, this number is like a 1. In the first term, it's like a 1x cubed. And in the second one, the coefficient's a 3. So 1 and 3 don't really have any common factors other than 1. So that's not very interesting. But the x squareds and the x cubes, they do have some in common. We could think of this x cubed as an x times x times x. There's 3 x's multiplied together. And the x squared is an x times x. And so, to me, I see that they have, in fact, 2 x's in common, right? There are 2 x's in at least both of these terms. So what we're going to do is we're going to pull out an x squared term from both of these. We're going to divide out an x squared, and then rewrite it out front, just like we did in Arduino. So I'm going to start by writing the x squared out front, and now I just have to determine what's left over after I've pulled out an x squared, divided out an x squared from both of these terms. Well, from the first one, I have an x cubed divided by an x squared. That means I have 3 x squareds multiplied, and then I'm dividing out 2 of them. That's just going to leave me with 1x squared left over. Or sorry, 1x left over. Or you can think of it as x to the first power. And then the 1 doesn't really change. It's still just a 1 there. For the second one, there's a 3x squareds divided by an x squareds. Well, if I have 2x squareds multiplied, and I'm dividing 2x squareds out, that means I'm going to have no x squareds left over, or this thing is just going to simplify to 1. So I'm going to have just a plus 3. So we picked out the biggest factor. We noticed the greatest common factor here on GCF is x squared. It's the biggest thing that was in both of the terms. We divided out of our terms and then rewrote it out front. Okay. Let's do the same thing over here. Looking at these terms, we already decided that 9 is a factor of both of these, and that's definitely going to be the biggest coefficient factor we can get from this one. And so let's pull out, and then for the x's, sorry, there's no x's in, x's are not in both of them, so x won't be a common factor. So we just want to take out at least a 9, hopefully more. Our goal is to factor this so that it looks like this term over here in yellow. Our goal is to factor it so it looks like x plus 3. So if I'm looking ahead to that, I'm like, I'd like actually to divide out a negative 9. A negative 9 from both of these. Then hopefully our factor will look a lot like the other one. So if I divided out a negative 9, again, that's our greatest common factor. We're calling our greatest common factor a negative 9. I'm going to rewrite it with out front, negative 9. And I have to figure out what was left over after I divided it out. Negative 9 divided by negative 9 is just going to be a positive 1x. And negative 27 divided by negative 9 is going to be a positive 3. Cool. So let's zoom out. I'm going to clean this up a little bit. I'm just going to write this as an x plus 3. And I'm going to rewrite our other one over here as just an x plus 3, because that's what they are. So now, on this first phase, we grouped it, we picked out our greatest common factors, and after factoring them out, we ended up with this same factor left over. All right, so now we're going to apply the same process. We want to simplify this just into factors. We're going to apply the same process to pull this x minus 3, or x plus 3. It's a common factor now. We want to pull it out, just like we did with our other greatest common factors, x plus 3 and x plus 3. We want to pull that x plus 3 term out of our binomial so that it'll just be simpler factors. So it's multiplied to both. I added parentheses because we're going to think of this as one whole group now. I added brackets. I'm dividing out an x plus 3, so that leaves us x plus 3 divided by x plus 3. That disappears. X plus 3 divided by x plus 3, that disappears. So once we pulled it out, we're left with an x plus 3 out front. And then what's left over inside was just an x squared and a minus 9. An x squared from there, from that first one, and a minus 9 from the second one. So what we've done now, we got to zoom out a little bit and kind of get a feel for what happened. We started with this cubic polynomial, and we grouped it, factored out some common factors, and we ended up with these two factors, which is a lot better because it's closer to what we're used to seeing when we find solutions equal to 0, with terms being multiplied together. So the first one is x plus 3 times this x squared minus 3. Now it asks us to find all the solutions. Right now we can find one solution using this first linear term. X plus 3 is equal to 0. And that's going to give us a solution of subtract 3, x equals negative 3. So that's one of our solutions. But we should also be able to get some solutions from this quadratic, that's left over on the right. So it's a quadratic. We have a lot of tools for dealing with quadratic factoring. Let's look back at our note sheet for some examples. We have all those differences of squares and cubes, and then we also have factoring with diamond box method, quadratic formula. In reality, diamond box method, quadratic formula would definitely work in this case if we know how to treat that middle term. But if I'm looking at right away, I see, oh, like a difference of squares. We have a squared term minus another number, which is a perfect square. So we can write this as a squares problem. If I think of this as my a squared minus my b squared, I know that that's going to simplify to an a plus b and an a minus b for my difference of squares formula. Well, in this case, my a is going to be equal to saying what times itself would give me x squared. Well, it's going to be x times itself to give me x squared. And my b is going to be equal to what times itself is giving me 9. 3 times itself is giving me 9. So a is x, b is 3, and we're going to get an x plus 3 and an x minus 3. And those are all still equal to 0. So after we grouped our factors, factored out the common factors, we were left with a single linear term, which we can get a solution right away, and then a difference of squares, which we can split up, and then that'll give us 2 more solutions. We have an x plus 3 equal to 0, minus 3, minus 3, x equals negative 3. So we actually ended up with that solution again, and then x minus 3 equals 0, plus 3, x equals positive 3. So we found now at this point 3 different solutions. 1, 2, 3. Well, actually, we found 2 different solutions. One of them has multiplicity too. We found 3 values of x that would make this true from each of the 3 linear factors for this equation. So when I'm finding all the solutions, I would say, let's summarize our solution and the multiplicity. Multiplicity. So the first solution we found was x equals negative 3. And that actually showed up twice. That came twice out of our solution. And the last one is x equals 3 is a solution, and it has multiplicity. It just showed up once. So grouping has a lot of steps, but it gets easier as we practice seeing the factors. So what I'd like us to do now is see, to try out this next example, and it's be a slow process, but what I'd like you to do is look back on your note sheet. I included another summary of another example that's all worked out, including a step-by-step walkthrough, right? Step 1, we look for groups that have common factors, and then we divided out common factors to make the same group. So once we picked out our common factors, we divided them out, and it was important that we made sure that we had the same group after we divided out our common factors. And then in step 3, we factored out that larger group. So that same group that we got, we pulled it out of our expression, and we were left with that thing times whatever was left over. And then now we have a linear term and a quadratic term we can solve. Great. So back here on our notes, take about, I would pause this video, I would go on and try and find these solutions by grouping, right? So I would group our terms first, pull out our factors, and then solve for the solutions. So you should definitely try that out on your own. What I'm going to do next is I'm going to walk through these. So hopefully you paused it, tried them out, and then once you've done it or you got stuck, you can go ahead and walk through it with me afterward. But I'm going to start on these, so hopefully you've tried these out. If I look at these, I'm just going to pick a couple groups to see if they have common factors. If I use this one, I see there's at least 2 x's in each of these. So hopefully I can use that as a common factor. In the second one, I see there's at least a 4 in both of these. Right, there's definitely a 4 there and a 4 in 20. Yes, 4 goes into 4 and 4 goes into 20. All right, so and we kind of picked our groups and we saw they do have common factors. Now I'm just going to try and pull them out. So what I'm going to do here is for the first one, I'm going to pull out my x squared. I'm going to divide out that x squared because that's our biggest factor and pull it out front. So x squared is going to end up out front. X cubed divided by x squared is just x, minus, and then 5x squared divided by x squared is just going to be minus 5 left over. So that's our first one, and we made this group of x minus 5. Now for the next group, I noticed the 4 is common. So let's just divide that out and see what happens. Maybe it'll get us the same group, maybe it not. But we should be able to fix it. So if we divide out a 4 and pull it out to the front, we're going to be left with a 4 on the outside. And on the inside, we have a negative 4 divided by 4 is going to give us a negative 1x. So negative 1x, negative x. And the second one, we have a 20 divided by 4, which is a positive 5. So at this point, we're close. We wanted these two terms to be the same, though, and they're really close. The first one is x minus 5. The second one is negative x plus 5. I wonder if there's another factor I could pull out of the second one that would allow it to be exactly the same as the first one. So let me see if I can find another factor that would make this true. The first one has a negative 1 times x. And then I could also pull a negative 1 out of this 5. I could think of 5 as like negative 1 times negative 5. So let's do that. I can pull out a negative 1 from both of these. So hopefully that'll help. Negative 1, divide out a negative 1. What I divide out, I'm going to have to put out front. So this is going to be an x squared, still times an x minus 5. And that's what we want this one to look like when we're done. When I pull out a negative 1, it's going to be a 4 times a negative 1. So it's going to turn to a negative 4 out front. And then a negative 1x divided by a negative 1x, that's a positive x. Good, so that's the same as the first. And then a positive 5 divided by negative 1 gives us a negative 5. Right. So we initially tried 4 as our second one, but then we realized it gave us the wrong sign. So we wanted to fix the sign, so instead we pulled out a negative 1, and then we ended up with the same group. Great. Again, I'm going to make this bigger group. I noticed that there's a common factor of x minus 5. I'm going to get rid of that. X minus 5. Get rid of the x minus 5. And pull it out front. So it's going to be x minus 5 times x squared was left over from the first one. And negative 4 is left over from the first one. All right, well, that looks a lot better. This is a linear term. We can get a solution from it right away. X minus 5 equals 0. That's going to be x equals positive 5. The second one, again, this looks like a difference of squares to me. Difference of squares. So if I look at that, I'm like, oh, my a is going to be a times what? What times what give me x squared? X. B, what times what give me 4? 2. So this is going to split up into x plus 2 and x minus 2. And then I'm just get our solutions from that. X is negative 2 or x is plus 2. So it said find all the real solutions. Let's list those now. Solution, multiplicity. 5 came up once, x equals 5, it just happened once. X equals negative 2 happened once, and x equals positive 2 happened once. So again, these do have a lot of steps, but as we practice with them, they get easier and easier to start to see the patterns. Looking at the third one, exercise 3, find all the real solutions to this one. I notice, again, this first term, they at least have an x squared in common. That first group. The second group, it at least has a 2 in common. And if I'm starting to think ahead this time, this looks a lot like the problem we ran into last time, where the sign here on the 16 is wrong. We want the sign to be a negative in the middle after we start dividing. But we'll keep an eye on that as we go forward. So let's try this thing again. I'm going to divide out an x squared, divide out an x squared. So the first one's going to be an x squared times, it's just x, and that is going to be a negative 8. So again, divide out an x squared and pull it out front. For this one, we said we're going to divide out a 2, because that's the biggest factor we could think of. 2 goes into 2x, and 2 goes into 16. So if we pull out a 2, it's going to give us a negative x plus an 8. So again, this gets us pretty close. If we want these to be the same, they're almost the same. They're just different by a factor of negative 1. So we can pull out a factor of negative 1. That's going to give us x squared times x minus 8. And then 2 times negative 1 is negative 2. And then negative x divided by negative 1 is just x. And 8 divided by negative 1 is negative 8. Now we have the same factor. We have our bigger group. We want to undistribute. We want to imagine we're pulling this factor out. So we're going to divide it out of these two terms. Divide out of these two terms. It's going to cancel, 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 cancel. We're going to get left with x minus 8 times x squared was left over from the first term and negative 2. And this is all still equal to 0. It's always been equal to 0. Process, right? We looked for groups of factors. We found big factors. We pulled them out, made any adjustments we needed to, and then we're just left with this. We can solve this one right away. I know that's going to give me a solution of x equals positive 8, because 8 minus 8 would give us 0. Oh, solutions to this one. This again, it could look like a difference of squares to you. We got a square and a minus. With difference of squares, you can solve that. We could do it that way. Let's do that, difference of squares. So a squared is going to be matched up with our x squared minus, and this is like our b squared. So here it looks like a is going to be what times what gives me x squared. A is just going to be x. And then for b, it's saying what times what would give me 2. 2 is not a perfect square, but we could use the square root of 2. The square root of 2 by definition is the thing times itself that gives you 2. Another way to look at this is we could say b squared is equal to 2, and then take a square root of both sides. So b is going to be equal to, technically it's going to, oh, sorry, not 8, it's going to be equal to 2. Square root of 2. So b is technically going to be equal to square root of 2. Actually, it's plus minus, but we don't really worry about that because when we plug it in our formula, it doesn't matter. But this is going to be, so it's going to be a plus b and a minus b. So that's kind of a new one where we didn't have a perfect square in our difference of squares, but we know that square root of 2 times square root of 2 does still give us 2. And that gives us two simple solutions. X is going to be the negative square root of 2, or x is going to be the positive square root of 2. Great. So we found 3 solutions to this one. Again, solutions are going to be x equals 8, x equals negative square root of 2, and x equals positive square root of 2. And then if we wanted to include the multiplicity, each of these only happened once, which makes sense. Our original equation was degree 3, so we should get just 1, 2, 3 solutions to it. All right, that's it for our walkthrough. If you need more practice, there are 2 problems, 3 problems at the bottom of your note sheet summary. Right, so if you'd like to practice some more, there are 3 practice problems there. But once you feel comfortable, come in, ask some questions, and take your exit ticket to show mastery on this lesson.